Hello, this is part 7 of our game making tutorial for beginners. Last time we made it so that when you walk into an enemy, you explode into little fragments, and the little fragments piece themselves back together. And that's cool. It took longer than I expected, it took 40 minutes, which is, I was trying to keep these for about half an hour. But it's good because it lays the groundwork for what we're going to do next. After we make the player explode, now we want to make the enemies explode. And so actually, I think I'm going to create a new enemy type for this. So we're going to leave our shrinking enemy as he is. And we'll make a new sprite. Just duplicated that one. And now I'm going to edit it. I think we'll start from scratch. But again, it's good to have the same canvas size as before, so you know how big the thing you're drawing is relative to what you had before. And let's make this one, I guess, red to distinguish him. They'll probably be a bit bigger than the player still. And then there's like a spray brush thing, and we could do like slightly brighter reddy bits. Maybe they'll be a little bit orangish. Is this going to work? Doesn't really matter, does it? Okay. Let's do a couple of darker bits too, just to increase the contrast. I don't know what I'm doing. It's terrible. But we can give him. Let's give him just one big eye. I want to make them different in as many ways as possible because that'll just help the readability, help you spot, make sure the player knows for sure, even at a glance, that it's a completely different enemy type. Okay, looks like an amoeba type thing. Should we crop it? No, let's just we'll tick that for now, and then we'll click the center button. Oh yeah, it's dead center, that's fine. Okay, so now we called our previous thing enemy, we'll have to rename that. But we want this to be exploding enemy, so let's just call it exploding enemy. And I'll probably use that name for the object too. So we will. Should we copy the object? Yeah, let's copy it. I'm going to duplicate the current enemy object, and I'm going to call it O exploding enemy. And then let's look at what code. Oh yeah, first remember to actually change the sprite. Let's look at what code we already have. That determines his speed, and his direction is random. We'll leave that alone for now, I don't care about it. And this says face the direction you're going. This says bounce off the edges of the room, that all seems good. And this says die when a bullet hits you. And we'll change that, but it's good that it's there. So actually, yeah, it was a good call to duplicate the whole code because most of this is stuff we want to use. But we will get onto something that will help us with this. Let me think. We want this guy to explode into a bunch of fragments, and we've already written code for that. Not on the player chunk, but on the player himself, or herself. And when the player touches an enemy touching me is this. If there is one, then we go here, and we set up this counter, and then we go through a loop creating all these chunks. Each of those chunks is going to give itself a random direction and a certain speed, and then they'll all fly out and we'll play a sound of us dying, and then we destroy ourselves. Most of that stuff we want to do on the enemy. Obviously, we're not going to make the enemy a clone of the player, but this whole behaviour is pretty much what we want. I guess just this bit really. So I'm going to make it into a script, and scripts are a thing that's super useful. I've been sort of avoiding them until now just because I wanted to teach them when they would be really handy. But they work a bit differently to how a lot of programming languages work. Hopefully you're a beginner so you don't know how the other programming languages work, so that will make no difference to you. But the way a script works in GameMaker is, I'm going to make one up right now, so I'm going to say, I'm going to call a script that's explode into not just bits, a number of chunks. And so you know where we do stuff like instance destroy, that's a function, we write the special words and then we put brackets after it. This is like declaring a variable, but we're declaring a function, or we're about to. So we just made up a name for it, and then we put the brackets afterwards. You always have to have the brackets even if you don't need to give it any information. And that's basically kind of what tells GameMaker that it is a script or a function rather than a variable. This is going to do something in and of itself. We don't have to say that equals something, we don't have to say something equals that. It can just be written there, because that is going to stand in for when we make it. It will be all this code. So we're going to put all of that code into a script, and then every time we say this word, this big long string with the brackets, all of that code will run. And that is literally true. The way to think of it is, at least this is how I read it described in the GameMaker help files, all of the code that we put in this script, it's as if we just copy and pasted it into every place that this word is mentioned. So first of all, we're going to get it working on the player, and then we'll move it over to the enemy. So right now I've written the word. You can see it's coming up as an error because excuse me, that function doesn't exist yet. And these are things we do need to set up, because it needs to know what code we want to run, and this is the code we want to run. So I'm actually just going to copy all of this, select it all, Control-C, and then we can just move this out of the way. And then we go to the script category here, and we say right-click on it and say Create Script, and it'll open a new code window. Just paste all that stuff in there, and now the reason I've included this name when I copied it is because I want to just paste this into the name box up here. This is where you define what. This is not just the name of the script, it's the words you type to call the script every time you want to use it. So I will let's just tick that, and then you've got to remember, obviously, if you're doing it my way, which is I always do it this way, where I write the name of the function, and then above all the code that it's going to be, then I copy and paste the whole thing, because we need the name in the script as well. But now, hopefully if I just get it to realise, it had to kind of refresh its knowledge of what scripts exist, but now it's gone orange because it recognises, oh yeah, I know what that is. You made a script about that. So now we can delete all this code, and this just says now, if an enemy touches me, then do all of the code that is in the explode into a number of chunks function. And like I said before, you can middle click anything in GameMaker to kind of go to its definition, except your own variables. Actually, I'm just going to try that. No, that just opens the help. But you can also click your own scripts. So if you middle click your own script, it will open that script, and that's really handy because you're going to be jumping between these a lot. And we can see what code's running. So we don't need to test this because I'm just telling you it. That is, what we've written there is exactly what we had before. Like, having that word there just substitutes in all of that code into that slot. And we know that code works because we just tested it. So now we want to put it on the enemy, on this new enemy, the exploding enemy. And we got all the normal behavior code which is inherited. As you can see, this is kind of clumsy because we've copy and pasted this guy, so we duplicated him. So all this code is repeated, and what we want to do eventually is put all this into scripts. So this one will just be like a script that says bounce off room walls. This will be face the direction you're going, whatever, we'll make it all up. But we're going to start with a more interesting one because the exploding thing is what we're interested in right now. So we don't want the bit that's about shrinking ourselves. This is where commenting the code is helpful, because now we want to change this behavior and we can see exactly the destroy the bullet thing. We want to keep that. I'm pointing to it as if that's going to make any sense. The shrink ourselves bit we don't want, so we just delete that whole chunk. And then destroy us if we shrunk ourselves into oblivion. No, we don't want that either because that's relating to shrinking. But we do want explode. In fact, if I just type the first word, it will pop up. And again, we've got to put the brackets so that it knows we're talking about a script and we're not passing it any information yet. So you can probably imagine this is going to cause some problems. This is not good code yet. This is, you can see this is going to cause some bugs because that is literally the player's code. It's going to make chunks of the player. And I don't actually know, it'll probably crash. Will it crash? I don't know. Let's find out. Oh, we didn't make one. We forgot to actually put an enemy in the level. Let's open up our room. Go to the Objects tab, select the exploding enemy, and we'll place one nice and close to us. So you can do the ceremonial check that we are recording. Yes. And now we just. So when I bump into him, nothing happens at all. Oh no, sorry, it's when I shoot him. I was trying to kill myself. He reassembles into a player! And now we can both fire. Now that, I think you'll agree, is an interesting enemy type, if nothing else. We can move them closer together, I guess, by doing this. So that's what, if you're thinking about it, that's what you'd expect to happen, right? We didn't tell it not to create chunks of the player, we didn't tell those chunks of the player not to reassemble into a player. When we assemble a player, we don't check that there isn't one already there. And again, the golden rule is nothing happens unless you tell it to. We didn't tell it to avoid this situation. So it's created this situation. And this is like, it's giving me ideas. I like this. But that's not how we want it to work, obviously, for now. Maybe that's a sort of, maybe that could be a power-up you get or something, or some other bonus item. It shouldn't be what happens when you just kill this enemy type, because if that happens, it's going to get chaotic quickly. And if you have more than one of those enemy types, it will make the game just too easy, I guess? I don't know. It's not even, it's so primitive at the moment, it doesn't really have a difficulty. But all we want to do for now is just have an enemy that explodes into its own chunks of stuff. So clearly we want to change which kind of chunks come out, and maybe even how many of them, because right now if we look at our script, it says the number of chunks to create is this, it's the number of bits the player is made of. There's no reason the enemy should be made of the same number of bits as the player, and so if we change that later, or if we just, it just may not be appropriate for what we want. So we don't want that number in there. And the other thing is that this specifically says create chunks of the player, and we don't want to do that. So there's two bits of this that need to change. And so we will end up, we'll keep this script, but we'll end up making those things that we can change. There will be arguments, which is a kind of variable that you can pass to a script. I guess you already know that, because all of these are arguments, where we say audio play sound, that player death file name, that's an argument, that priority is an argument, that check of whether it should loop or not is an argument, and now that we're writing our own functions, we can pass in our own arguments. So first, actually let's do it bit by bit. So if we could just write, replace all this, I'll cut it, and write argument 0, and that'll be the first argument that gets passed to it. I don't really like doing that because it's not obvious now. Now our code doesn't read very well. When it says bits created so far is less than argument, what's argument? You don't know off the top of your head. So if you've forgotten what this code does, you won't be able to read it and back to yourself and understand. So instead we're going to set that, we're going to store that in a variable. So we'll just say number of bits to create equals, so no, not that, equals argument 0. And now we can just copy that and paste it in here. So bits created so far is less than number of bits to create. Now we know what that says, that makes sense. And that is a thing that we will vary. So that line up there says that, I'm actually just going to unindent that by pressing Shift Tab. Because we can see there's argument 0 up there, this is now a function we've got to pass something to, got to have something in the brackets. And when we wrote it in our player function, we didn't put anything in brackets, we left them blank. So now this needs to be, let's look up exactly what the name is. It's the thing we define in the create event of our game object, number of bits the player is made of. So O game, number of bits the player is made of. So now it's going to substitute that into the code in the relevant place. And we'll get the exact same behavior that we had before. For the this could be interesting. For the exploding enemy, let's go back to him. Open up his code, and we've got to put a number in there. If we don't put a number in there at all, the game just won't run. It needs some kind of number now that we've said we're expecting a number. So let's put 25. So it's 9 for the player and it's 25 for this guy. So when we shoot him, 25 bits of the player are going to come out now. What I'm interested in is what happens when they reassemble, because they're all going to go to the same place, but when it has 9 of them, it should create a new player. So we might be creating 2 players in the same spot. Yep, that's a lot of bits. Because it destroys them all when one player is formed. Yeah, so that's not the code we would have written if we were actually going to intentionally do this. But again, a big outstanding problem is that we're creating an extra player we don't want. So we're going to need to create a new fragment type, and we want it to look like a chunk of this enemy, so we'll duplicate his sprite, we'll open it up, and we'll make this the same way we made the previous one. There's an eraser, make it pretty hard, And we'll do something like this. That doesn't need to be particularly slender, I suppose. And now I'm actually going to just copy it and delete the whole thing and then paste it and then say transform and crop it down to the actual size. Actually, because a lot of like semi-transparent pixels get left over and they can change how big GameMaker thinks this thing is. Oh, the other thing is we need to flip it because everything should face right, and when it's flying out you want the fat end facing away, facing the direction it's flying. We'll enter that and we'll name it S. Exploding enemy chunk. I am never one to shy away from a long name of something, as long as it's clear what it is. So now, I think we will duplicate this one, the O player chunk, and say O exploding enemy chunk. We'll set it to be the right sprite, and when it's created, now the speed is pretty good. It's okay. Well, do you want to change the speed? I think we could have it less than that actually. Let's make it like only up to 1,000, between 500 and 1,000. So the explosion of this character will be less dramatic than the explosion of the player. Direction still random, that makes sense. All this original X, original Y stuff, that's to do with reassembling, so is that, and so is imposition, so we don't need any of that, we're just going to delete it all. So in general you don't want to be copying and pasting code, but in this case we need to set speed and direction. Direction is literally the same as it was in the previous chunk. There's no point in writing a script just to store that one line. And speed, we're actually setting it to something different, so again there's no point in making that script. So we'll just say OK to that, and we're cutting out all the rest of the code. So now we go to the step event. I'll see whether this should be a script or not. Probably not. I think the difference between this chunk and the player chunk, they're quite subtle and they kind of go throughout all of the code, so probably it won't divide easily into a bit that we can turn into a script and a bit that we can't. We only need deceleration because these bits are going to slow down as they fly out, but they're never going to reassemble. We don't need this stuff about whether we're reassembling or not. Reassembling equals false. All this bit, we can see from our comments, we are still flying out from the initial explosion, so we do want this bit. That is, we'll still be doing that in this thing. But this whole chunk down here, we stop flying out and now want to be stuck back in. Because we commented that nicely, we know we can just delete all of that. And this if reassembling false, we don't need that check, we don't have that variable at all. This line about reassembling equals true, just delete that, that's not relevant. Head in the opposite direction, we don't want to head in the opposite direction. When we explode, we don't want to suck back in. And what is all the rest of this saying? It's saying if we've still got some speed to lose, then reduce our speed, keep facing the direction we're going, and reduce our speed. And if we don't have enough speed to lose, if our speed is so low that subtracting deceleration would make it 0 or negative, then we just stop. And all of that we want to do, right? That all seems pretty reasonable. So our code's got a lot simpler, and hopefully, I went pretty fast there, but hopefully if you go back through it, all the bits I deleted were relating to reassembling. We don't want to reassemble. So let's just tick this. We've made our type. Now we need to tell the enemy to use it, exploding enemy. So we'll open up his code. I'm going to middle click on the explode into a number of chunks function, because now we want to pass it a second argument. We've told it how many pieces we want, now we want to tell it what kind of pieces. Type of chunk equals argument 1. So you do have to remember that argument 0 is always the first one, argument 1 is the second one. A little bit counterintuitive if you're not used to starting from 0. That's just a programmery thing, like all counts start from 0. So here where we said O player chunk, now we don't want it to always be the O player chunk, we want to listen for what type of chunk we've been asked to fling. Always listen to what kind of chunk someone has asked you to fling. So this should be it. We've got number of bits to create, type of chunk, those are both passed as arguments. That function is now done. And here, where we say 25, well, now we've got a second argument to pass, so we comma, and we say explode. Again, I'm just going to start typing it and wait for it to pop up and autocomplete. That is good both because it lets you be lazy and also because it ensures you get the name exactly right. That's good for our enemy. Do you think 25 is okay? Yeah, why not? And what about our player though? If you do, so the advantage of scripts is that you can change that code now. I can tweak it, I can change how it works, decide it on a new system, and I only have to change it in one place. But if you're going to change the number of arguments it takes, that's a big fundamental change to what that script even does. And so obviously you have to go through all the places that you call it and make sure you're passing the right number of arguments. So this one, that whole word is just the number of chunks it wants, and now we have to do comma, type of chunks it wants. Player chunk, right? Yeah. So when you are planning your functions, decide ahead of time how many arguments you want to pass to it, because changing that after the fact, if you've used it in 100 different places, could be time consuming. Sometimes you might want to just make a sort of a new version of the function that takes a different number of arguments if you want to use it in some new place. I don't know, we're getting way ahead of ourselves there. Let's just test this for now. So hopefully no more extra players. Yes, wow, oh my god. Okay, so the bits he blows up into, they're pretty big. So that guy shrinks and the other guy blows up. It's quite spectacular. They slow down a bit fast, don't they? I guess because they have less initial velocity, so it looks more obvious. They are pretty big. I think I'd like them to explode faster, maybe decelerate faster too. But also they're going to be lying around, and just having them lying around everywhere is kind of visually noisy and distracting. And also once we have a bunch of these, it's going to just create a whole load of objects that aren't doing anything and aren't that interesting. So I'd like them to disappear, but I don't want to just blink out of existence because that'll look bad. I think they should shrink. I like things that shrink, you might notice. So this is the cool thing. Now we've got that script that just blows things into chunks. Our blowing chunks script. Then we don't need to change the actual script. We can leave the script alone because we can vary which type of chunk is being sent to it, and we can edit the chunks individually. So without touching anything to do with how the player works, we can change how the enemy chunk works, and its exploding behavior will change, and we can still use that script in both places. So I think maybe I'm going to up deceleration to like 2000. Doesn't matter about the values for this, just make up whatever you like, or don't change them at all if you're not unhappy with them. I want to increase the initial speed. I think the players was pretty good. We just wanted it to slow down faster, which is a weird thing to say. And then in the step event, so all I've done there is just tweak speed values, none of that was important. In the step event, we want to, let's just have the chunk shrink all the time. Image x scale, remember that's our width, equals image x scale minus, we want to subtract something from it, but we want that to be divided by the room speed, so that if we make that faster or slower later, it won't be affected. So what that says, 1 divided by room speed really means in every second we'll reduce this by 1, and image x scale is 1 by default. So we're essentially making it disappear within 1 second. Image y scale equals image x scale. That just says always be the same aspect ratio that we were originally, and we don't need to do that maths again. So that will shrink it, and then we should also say if image x scale less than or equal to 0, open braces, instance destroy, but with an n. And that is literally the same code that we had in our enemy that shrinks and destroys himself. So let's give this a label though. Shrink over time. We'll annotate this to 1 second to shrink to nothing. 1 divided by room speed means 1 second. Or 1 per second. And yeah, we might as well just annotate this to destroy when vanished. spelled that wrong, but I don't care. So let's see what that's look like. Ooh, interesting. I like it. It's really dramatic. It's something like, I think it's because it's sort of bright red on a mid blue background. Something kind of interesting about that. I feel like it should just be a bit sooner. Obviously, it's fine, but I kind of don't want to see them come to a rest. So we could actually just give up and put the deceleration value back to what it was. Something that would fix it. Or actually, I guess we could just fade out faster. Yeah, let's leave that as it was. Is that what it was? 2000. Yeah, okay, that's what it was. So this thing where we say 1, let's try 1.5. No, wait, sorry. Yeah, 1.5 divided by room speed. That makes sense. So we'll lose it in less than a second now. In fact, I didn't change my comment, but I will. Alright, I like the way that looks. Now, let's try... Right now our game only has one of these guys. Let's just, for the sake of experimentation, face a whole bunch. Just see what it's like to fight a bunch. We could put maybe one more big enemy too. Those guys are big and they take more than one shot. So I think they'll be rarer. They'll probably be like, not a boss exactly, but a tougher enemy that will be sticking around a bit longer than the other ones. Let's try blowing up a lot of things. Actually, it looks great. Really like it. Well, that was an easy demo. So, the explosion looks really cool. It would be quite nice if we had those chunks. Well, I remember, I'm just going to change this comment. When one of those chunks hit an enemy, if that hurt the enemy, if it was like a bullet hitting the enemy. And that would mean, if it hit a shrinking enemy, then it would shrink a bit. If it hit an exploding enemy, the enemy would explode. And then his explosion would cause more shards, and then more chunks, or whatever you want to call them. Those other chunks could hit other enemies and cause like a chain reaction. That could be fun. Anytime things can interact with each other, rather than directly with you, is an opportunity to make the game more interesting. The most straightforward games have no interactions between anything except the player and that thing. So player and enemy, player and obstacle. But all the games that I really like involve enemies interacting with each other, enemies interacting with the environment interacting with the environment, and those things having some relevance to what's going on. So this is the most crude example of that. Enemies could blow each other up. It's the exploding barrel in Doom, right? I mean, this is literally very similar. But also that was shooters getting interesting. Whereas, oh, now the barrel can affect the enemy. And also the enemies can affect enemies in Doom. Do you remember that? Like if they accidentally shot each other, they would just start a fight between each other. That was great. We could do that, except most things only take one hit. So I'm just going to remove that comment because I don't want to have to keep updating it every time I change that value. We want shards to hit other things. So these scripts that we're creating, we'll create a bunch more. In fact, I'll do that now. I'm going to create another script just to just so we don't have this duplicated code. So if you remember our original enemy, he had a bit of code that said he should bounce off walls. Let's just write that as bounce off walls, brackets. And now I'll select it all. It's an error for now because that doesn't exist. And we'll find the scripts section, right click, create a script, paste all that in there, paste the bounce off walls part into the name box, and that is now a behavior that we can put anywhere we like, and anything that has an X value and that is in a room and has H speed and B speed and all that can run that code. And so now we should find, we're going to delete that, that goes orange to indicate it knows what I'm talking about. So we're still going to have the same code in this and the other, and the exploding enemy, but the difference is if I one day change how that code works, I just have to change it in that one place. Both of them will know what that means. The facing thing, that's so simple that we don't need to make a script out of it. I might want to change what an individual enemy does, where he faces, why he faces that direction, but I'm never going to change the code for how we say face the direction you're going. That's what that says. It says face the direction we're going. There's no other way of doing it. It doesn't get much simpler than that equals that. So we're never going to change how that works. We might change what we wanted to do, but if we do that, it's okay that we have to go through and change individual enemies, because we want to think about which enemies do we want to change. Do we want some of the enemies to keep looking in the direction they're looking in? So that's just kind of a way of thinking about when to turn something into a script and when not to. Turn it into a script if there's any chance you might want to change how it works, how it achieves that goal. You don't really want to make a script of something that you might change what it does, because the name of the script itself is going to have to say what it does. You want these to be really clear. I mean, the great advantage of them is that they're so clear that you almost don't need this heading anymore, right? We used to have a heading for a whole chunk of code, because there's a big chunk of code, and any given line of it, if you read it in isolation, you wouldn't know immediately what it meant. But now, the whole line that does all of this actually says what it does. It says bounce off walls. So that's as good as any comment we could write. So we can just leave that there. And now, in fact, the next bit we want to look at is this also. So this says when a bullet hits us, we should destroy ourselves. The way we're going to do this is, scripts are great for pulling out like an individual bit of code and making it a behavior that you can give to different enemies. Sorry, I'm having trouble speaking tonight. I actually did a practice. I'm giving a talk at GDC in March, and I did a practice of it today, and it's an hour long, so I've already talked for an hour to this computer today. Any object-oriented programmers watching this will be possibly thinking, hey, you should have made a parent enemy type and then had both the enemies be children of it, and then put the universal behaviors on the parent, and then had that. That won't make any sense if you're not an object-oriented programmer. But we are going to make a parent now. So the behavior we want, I'll go back into this code because I want to explain why we're doing this. This thing checks for a bullet. What we want it to do is check for a bullet or a fragment of stuff. And so we could add a line of code that said, if you didn't find a bullet, then check for a fragment, for a chunk. But that's a little bit unwieldy, and then the variable name would have to be, I don't know. What we really want to do, we just want one object to check against. That will make our code much neater, it will make more sense, and it will be more universal. And so we are going to change how this works. And the way we're going to do it is we're going to create a new object that both bullet and chunk are children of. So we're going to create, I call these classes. In real programming, class means something different, but my definition of a class is a type of thing that will never in itself exist. We're calling this O projectile, and we're never going to make an object in the world that is just called projectile. That's not a thing. We're not even going to give it a sprite. It's going to have no code. It is literally just a category of thing. And what we want to be able to write is, hey, did a projectile hit us? And what we want that to mean is, did a bullet or an exploding enemy chunk or a player chunk hit us? Those are three different things, and we want to check against all of them with one word. And so we're going to make all of them children of the projectile. So now that we've created this category of things, projectiles, we want, if it'll ever open, to tell this bullet, hey, you are a projectile. So that means setting its parent to the projectile. So the little box down here, you click the little list icon, and then we select projectile. So now it says that all this thing's code is still the same, it doesn't affect anything else we've done. It just says, if we ever check for a projectile, bullet, that's one of them. And now we want to say, player chunk, you are also a projectile. And now we want to say, exploding enemy chunk, you are also a projectile. And now in the enemy code, which we should have turned into a script really, maybe before doing this, I'm actually just going to write it the hard way first, and then we'll see which bit of it would work well as a script. We just type projectile there, and that will be affected by everything that comes under that category. And so made a reference to object-oriented programming earlier. The one other way of sharing code between objects is to make them children of one object and then put the code on the parent. I don't like that because I did that for Gunpoint quite a lot, and it caused me problems because now that code isn't in here. This is the enemy step event. When I want to know when there's some bug with how the enemy's behaving, or I want to change how the enemy's behaving, I look at this, and right now this tells me everything the enemy does. All of his behaviour is all in this one sheet of code, and this might get very long, but I can just scroll through it and I know I'm seeing everything. If we put some code on the projectile object, the class, the category that all these things are in, every time I look at this I've got to remember, but in addition to this, it's also running some other code on a different object, and I need to close this window and open the other window to see what that code is. Then I've got to remember, is that happening before or is it happening after? And it's just much easier not to deal with that. So if I wanted to share some code between all these different things, I would write it as a script, like bounce off walls, and I would call that script in each of the step events. And then that thing, even though we've hidden a bunch of code, it's in a different window, I have to middle click to get to it. I know what it does, it has a good name, and I know where it is. I know it's happening after this, but before this. So that's why I like scripts for this kind of stuff. All of that is just a justification for why we're not doing something in a different way. So if you didn't understand it, it doesn't matter. As long as you understand how to write a script, that's good, and as long as you understand how to make a category, which we just have. So yeah, the thing I don't like about our code right now is that I'm going through here and I'm changing this in two different places. Anytime you're changing something in two different places, you should be thinking, isn't there a way I could avoid having to change it in two different places? And I'm really hot now, so I'm going to take this off. So, both of them check for a projectile, and hopefully that should mean the shards now work the same as bullets, including our own chunks. Our chunks will be as hard as bullets. I found myself saying some weird things since starting this. Yeah, look at that! We just had a chain reaction. Oh! But now we can't reform. So I'll restart the game and let's shoot some stuff. That works great. Shooting one of these. Oh yeah, that's fantastic. But do you know why we didn't reassemble just then? It's because, do you remember ages ago when we did our bullet code? In fact, I just demonstrated it really well there. If I shoot a bullet at that guy, shrinks him, but it also destroys the bullet. Our code says it checks for a projectile hitting us, and then it says damage us, but also destroy the bullet. And that was fine when it was a bullet, but now it's a chunk potentially of the player, and we're destroying chunks of the player. And the player doesn't reassemble unless he gets back as many chunks as he threw out. So we have made it so it's possible to get into a situation where you can't respawn, which is bad. You could make a game mechanic around that, but we're not going to. So I've got to tinker with that code again, and it's getting annoying to have to keep changing it in two different places. So I am going to write, instead of this setting up this incoming bullet thing and then checking against it, we will just write, I guess I'll write it up here. If hit by projectile. So now we are using a script as a check. We're using it in an if statement. We're checking against it. And that's fine too. So this bounce off walls thing doesn't take any arguments and it doesn't return any values. It doesn't. Like, you don't put anything in, you don't get anything out. Our explode into chunks thing, we give it some values, we pass it some arguments, but it doesn't give us anything back. It just does some stuff. It affects the world, affects us, but it doesn't return like a number. But you remember instance place, that checks for something, we give it some arguments, and it gives us something back. It gives us the name of the bullet that we've created, that we've checked against, sorry. And the function we're about to write, hit by projectile, we want it to return true or false. We want it to do all of this work, and we want it to also give us something back, just true or false. So again, I'm going to copy everything I've written. I preemptively write what our code will look like when we have that function, then I go off and write the function. I really like that. I really enjoy, one of my favourite things in programming is calling a function you haven't written yet. It's like saying a magic word that the universe doesn't know how to deal with, and you just say, yeah, it's okay, I'll figure it out. I'll make a function that does that. So I paste all that in there. Hit by projectile is going to be the name of the script, so I'll put it up there. And all this code, I think we'll say, we will change this to incoming projectile. We're going to have to do this in in this script. We don't have to worry about all the other places we reference this. So we look for it. We say, we look for it by checking against whether there's a projectile touching us. And if it does exist, we get this far, and this part destroys the bullet. We don't want to do that anymore. We might want to put that back one day just for bullets, but we certainly don't want chunks to be destroyed. And we also want to get rid of this explode into a number of chunks thing. We don't want that in this script. This script says hit by projectile, so all it's going to do is check were we hit by a projectile. If we were, return true. So I want to keep it close to the code we already had so that you understand what it's doing. And we are just going to say return true. So return means after this function runs, it will essentially be replaced by the result of it. So it will be replaced by the word true. So since our code says, I'll open up another window, our code says if hit by projectile, since hit by projectile returns true, this will just read as if true, and we'll get through it. That'll pass, it'll be affirmative. I've forgotten how to talk. So this is all the code that we just pasted, so we don't need that. So we also need to account for what happens if there isn't one. If it doesn't exist, then we return false. So it's sending a message back saying true or false. And this is, because this is an if statement, it'll either happen or it won't, and either way we return something. So that's good. So this thing will get back a true or false value. And I actually deleted a bit too much there, didn't I? I wanted to keep the explode into chunks thing, because that is what we want to happen. So we can delete the rest. So now it just says, if hit by projectile, explode into a number of chunks. And that code will check the same way that it used to check, by looking for the projectile. This doesn't give us an easy way to delete the projectile if we want to, but I can modify it to do that later. The way we would do that, I think, is to have that as an argument, maybe? I don't know. We don't need to think about it now, because that's tweaking. Essentially all we've lost is the bullets will now go through stuff, and that's fine, really, I don't care. It will make shrinking enemies easier to kill, but we don't mind about that yet. So, we're going to click the tick on that. That is our whole function now. Shall I annotate it? Yeah. Look for a projectile. If there was one, send back true. If there wasn't, send back false. That's all standard enough. And this, I can't even comment it because it's so self-explanatory. It literally says, if hit by projectile, explode into a number of chunks. 25 chunks, and it's the exploding enemy type. So again, that's the great thing about scripts, is they make your code actually say what it does, even more clearly than GameMaker already does. And so that's simple enough that we won't want to change how we do that. So let's go into the normal enemy, the shrinking enemy, and we can get rid of all this stuff because that's to do with checking hits. Paste this in. That's actually, we don't want the exploding into a number of chunks. Just going to replace the if statement. If hit by projectile, delete all that. So we could have, I'm trying to think how we could delete that bullet. We could have this function return the identity of the bullet, and then we could use that to delete it. I think it's better if we pass it an argument, but, oh yeah, I'll think about it. We don't need to do that with this episode because it's pretty straightforward. So that should be all we need on this thing. Yeah. So now, the player and the exploding enemy share the explode into chunks behavior, and the green enemy and the red enemy share the if hit by projectile check. So now, chain reaction still works, and the danger case is if I get killed. Oh, these guys don't kill us yet. Yeah, we didn't tell them to. Hopefully all the chunks come back. Yeah, all chunks come back. Fantastic. Yeah, okay, so I think we'll leave it there. I want to do some timer stuff next. I also want to... I've got some better sound effects I want to put in. And I think, yeah, we want enemy spawning, which will be part of the timer thing. And then after all that, I think we'll get onto like trying some weapon types, having you be able to switch between different ways of attack. But that's it for today.